let's start the event. So I'm very happy to introduce Dr. Markus Fischer, the chair of the steering committee of ITRPV. The organization is hosted by the German Engineering Federation, VDMA, and is doing a great job supplying the industry with the most important technology compass every year. Markus has been a driving force for this project for over a decade, and he's actually well prepared for heading ITRPV through his regular job, which is working on improving solar cell technology as a VP R&D operations at Jnaught Q Cells in Germany. I'm very happy to have you with us, Markus. The floor is yours.
Yeah, Michael, thank you very much for this kind introduction. So I will share my screen now. Okay, so can you see it?
Yes, perfect.
Okay, so thank you very much for enabling here the presentation of 12th edition of ITRPV. Yeah, it's the 12th edition, and the 13th edition is in preparation. So yeah, some data will be updated soon. So let me come to the outline. So I will first give a status on the PV learning curve, quite interesting in our days, and then on the results of the 12th edition. And especially I will focus here also on the maturity status. This is always the update we give at the end of the year. So to have here a review on maturity in the different value chain sections. And then I will close with an outlook and a brief summary. Okay, ITRPV status. We are collecting data from all over the PV value chain. In the 12th edition, we had 56 contributors from all over the world. And with the maturity report, we also comment in selected parameters about the maturity status. That means here gray is in mass production. Industrial solutions is known, but not really completely implemented. It's yellow, so then red is interim solution, and this purple is that there is a lot of research to do. Yeah, so this leads me now to the PV learning curve. Yeah, in end of 2020, we had 135 gigawatt of shipped modules. So average price was 21 US dollar cents. So so we are approaching the terawatt. So and if you look here, brief outlook about 2021. So we expect more than 160 gigawatt, but here the average price is first time during a long period of learning popping up. Yeah, so it's increasing, and this is very interesting to see what will be the next steps here in the technology. So and also production capacity was increased during this year a lot. So we expect about 400 gigawatt production capacity, and so we will see what is the current status. What we can see at first is PERC is currently the PV workhorse, and this is the current situation about the technology shares. So over the last years, the P-type material mono gained market share over multicrystalline. So this is now mainstream. Multicrystalline is about to disappear. And we see currently that a lot of new products appear, not only here multicrystalline modules in the past. So we see mainstream are mono standard products. And And here we see new formats popping up and also new high power class modules and bifacial. And you see here the average price calculation. We see, especially in the value chain, big challenges. So polysilicon price tripled within the last 6 months. And currently we see it quite stabilizing in the prices, but if we look on the spot market prices, so we see that cells are really big under pressure regarding the cost situation. So now let's come to the findings of the ITRPV. So I start here with a review about the formats. So this is well known. So over the long period, we had the 6-inch standard that was at that time introduced by Qcells. And now over the last, especially in the last 2 years, we see a lot of new formats for cells and also a lot of new formats for modules. So, and we see that new formats are dominating currently M6, M10, M12. So, and here we have in the ITRPV the overview of the formats, and we see very clear that the old M2 format disappeared. It's a small volume for multicrystalline still available. So M6, the 166 times 166 format, mainly in pseudo square, is currently here the largest volume. And then we see the new larger formats M10 and M12 and G12 for full square are expected to play an important role in the future. Okay, and the new formats require also a lot of efforts regarding the technology. So, and here over the last years, we follow in the ITRPV the value of polysilicon consumption per wafer. And here we see for the larger formats, this is in the maturity report included. So we see that the larger formats need also some more improvement and some more efforts to be really implemented. This follows this silicon consumption reduction, but nevertheless, we are sure that the silicon consumption will reduce. And I made here a brief calculation regarding not only the consumption of silicon per wafer, larger wafers need more silicon, clear, but there we see here, that smaller wafers consume less polysilicon per watt. And here, especially the large wafers are obviously, if we calculate here the watt per or grams per watt, that they consume a little bit more. So this leads me to the point that we have really in the future careful to watch the outcome here regarding grams per watt peak. And an important measure to improve the polysilicon usage is reducing the thickness. Over the last years, we had some delay in thickness reduction, but since 2 years, we see that from 180 microns now the 170 microns are mainstream for the M6 formats and also for the smaller formats. And we see here that especially for the large formats, the thickness reduction has to be implemented soon. And we also distinguish here between P-type and N-type. And we see that N-type is leading the thickness reduction. So this enables more efficient use of polysilicon. So regarding the technologies, so we see, as mentioned before, that P-type mono is the mainstream. And here we see also that, or we found that gallium doping is now in P-type mono the dominating and the only doping material. And we see also that here N-type is increasing share. multicrystalline is disappearing. So then we now, this is one of the topics, or this is the topic of this conference, to have a look at the technology shares. And what we found in the ITRPV is that currently the PERC and TOPCon technologies, so that means here all technologies with diffused PN junction are dominating. This is what we see, and if we have a closer look to this share here, this is the technologies of diffused contacts. We see that currently the workhorse is a P-type mono PERC, and we see that passivated contacts on N-type mono are increasing the market share, and here on N-type we also see that heterojunction is gaining market share. What we also found is that bifacial technologies will gain share, and this technologies, heterojunction and all this diffused PN junction technologies with passivations on rear and front are bifacial ready. So an important parameter in the roadmap is the Jnaught value tracking, and we see here for P-type. So there is the improvement on track. So this is what we see, and we see here that for P-type mono, so the Jnaught values are close, and we see that for larger improvements there is still some effort required. N-type has much lower Jnaught values, and this shows the big potential of N-type. So, and over the years we followed the trend, and so we see that we are quite well with the expected future predictions. So next point is very important, the metallization process, and we see here the trend of metal laydown, remaining silver laydown on the wafers, and we see here by sure for larger wafers we will need more silicon, more silver, and we distinguish here between heterojunction, TOPCon, and PERC. And we see that the PERC technology is using the less silver than other technologies, and this requires that here for N-type and especially for heterojunction, the reduction has to get really momentum and has to continue. How are these silver reductions realized? So mainly by increasing the number of busbar with reducing the finger widths, and we see that finger widths of below 20 microns, down to 20 microns are possible. And so the gray color marking shows that this is progressing to 30 microns, but here the 20 microns are not yet in the mass production. So regarding the silver consumption, so this is a big point. We have to consider currently with the PERC, we consume about between 6 and 10% of volt market, and if we come into the terawatt region, so we have really to reduce the silver consumption, especially for this higher efficiency concepts, to keep pace with silver availability in the market. So copper will play maybe in the future a role to replace silver. So regarding efficiencies, this is an important point that we have here in our conference. So we see that for the PERC technology, so these efficiencies are on track. So we reach currently 23%. And for N-type, this TOPCon, so there is a potential of 25% in mass production. So this is a mass production value. This is, will be in the future. So, and for heterojunction is leading. And we also expect that tandem will appear in the future, but the red marking indicates that there is a lot of development still required. N-type materials are dominating or are leading the efficiency the high efficiency products. Yeah, and on G and M12, so the efficiency are comparable, but need some more efforts due to the larger wafer. So, and regarding tool throughput, this is what we also looked here, and there we found that for larger formats, the tool throughput, this is important for the production sites, that here for larger formats, the tool throughputs need some further development and investigation to really meet this requirements that was indicated here. And for the heterojunction, so for especially for large formats, so there is still a lot of development required, but especially for chemistry and for the P-type tools. So this is quite well on track in the roadmap. So regarding modules, so we found in the past that here the shift from full cell to half cell was now or took place. So half cell is improving the module performance, and this will be the main product in the future. And we see for the different technologies here the module efficiencies, and we see currently we have the 21%. And what we will see in the future is that we will also reach at least 23%. And for tandem modules, we expect 24%. So this is still a field that needs development. And let's look here at the different module sizes. This will be also discussed. So with new formats, we see that the module sizes are increasing, and also the module weight is increasing. And this is a point we really have to take care for power plants. This is really important to have large modules with high efficiencies. So LCOE will profit from large module size in power plant application. But we have also to consider, so weight of 30 kilogram up to 40 kilogram, it has to be handled. And this is a point we have to consider in the future, and especially for the rooftop applications. So current modules are in the range of 20 to 22 kilogram. If this weight will increase and also the area will increase, this is a challenge for the mounting teams. And here in the last weeks, I also installed a PV system on my rooftop. And so the guys are really fighting with this large format. And we have to take care that special formats are especially for the residential products implemented, especially with this larger wafer formats. So this is a point I want to emphasize. So regarding module powers in mass production, in the past we had a very clear picture. 120 half cell or 60 cell modules were for residential, 144 cells are for power plants, but this picture is changing now. So this is also only an orientation about power classes. So for the 120 half cells, we see 380 watts. So new formats are appearing with more cells. And so this is not a real classic parameter we will track. So regarding LCOE, with this new power classes and with this larger format, so we will really continue the reduction of LCOE. And what we currently see that this is the expected trend for LCOE, and here we see here for the different insulation areas this trend, and we see here with current biddings in Europe. This is 5.5 cents per kilowatt hour. So we see that we are quite well on track regarding here this expected LCOE for kilowatt hour AC, and this trend will continue. And by sure, for this high insulation regions, we can reach the 2 cents per kilowatt hour in the future, by sure. So this leads me now to the outlook. As always, in the last roadmap editions, we have a look at the situation. How is what peak and per piece learning progressing? Because the price learning is always a combination of two elements. That means learning in efficiency and learning in power, and the per piece learning rate. So, and we found that the per piece learning has an impressive rate over the or since the years, since the last years, with about 20%, and the peak learning with about 7.5%, a little bit lower, and we see that it will continue. But I'm very curious about the outcome of this year, because at the year end the prices increased, and I expect that the per piece learning rate will a little bit get lower, for this year. So now my last chart. What is the situation of PV? So first message is, so we are really in the right industry, and we are in the industry that leads the transformation to green power generation. And in the ITRPV,
Markus, you are muted and we cannot see the presentation.
Something happened.
Yeah, I think there was some technical issue with probably Zoom. We don't know yet. But Markus, probably you have to share your screen again and start a little.
Markus, Markus, sorry, there was a little blackout, I assume.
Okay.
So I think when you started basically the conclusion slide, I think we also.
Oh, this is a pity.
We also, can you do that again, please? We all saw the learnings when you explained that, and then could you do that once again?
So from which page on?
The last one only, the very last conclusions page, the learning being all got. Yeah,
I was a little bit out of time, so but
please go ahead. So I think it would be nice if you could summarize again.
Okay, so I mentioned that the first message is that we are in the right industry with the PV, and we are leading the transformation of the whole energy generation market. And in the ITRPV, we show always here different scenarios, and here we also track for these different scenarios for the future, for future energy supply, especially for electricity and also for a broad electrification. We also track here the corresponding market. And this is an important message I want to give here. So the market is, again, is the internet is unstable. Yeah. So that the market is, with close to 200 gigawatt here required in 2021. So we are a little bit behind, but we expect that this can be realized. And we also found here this year, it was new published, the BNEF Neo 2021. So in the past, the BNEF Neo was a little bit conservative. And now with this latest release, they promised here also an increase in the market. And this is close to the second scenario. So close to this scenario that will require here in the next years up to 400 or even more, 450 gigawatt around 2025. And in the following year, 780 and 700 gigawatts in the market. So we are really about to approaching here this X100 gigawatt markets. They become reality, and we are approaching the Y terawatt markets. But for this terawatt, we need some more development and some more improvements. And for the 100 gigawatt markets, we can handle, but we have, especially regarding the silver situation, be careful and continue the efforts to reduce the consumption. ITRPV will provide also in future the guidance to handle all the challenges. So this is now the end. Thank you very much, and a special thank you for all contributors to the ITRPV. Thank you.
Thanks, Markus.
Okay.
Yeah, thanks a lot. I think you're, I think the whole industry, everyone who's involved is very much appreciating what you and ITRPV are doing. You're doing a great favor to the industry. Thanks a lot for that. I think since we are a little bit delayed, or a little bit more delayed, I suggest simply, if anyone has questions, please write them in the chat. Markus, if you have a few moments to spare, you might want to answer any questions in there, in the panel, in the chat function. Okay.